Today we're going to be talking about something called a literal equation. All a literal equation is an equation that has lots of different variables in it. A literal equation is an equation that contains many variables. The goal of a literal equation is to isolate a particular variable. Now, we are so used to solving for x, but in a literal equation, you might be solving for a variable other than x. It is helpful when trying to isolate variables when you're using formulas. So this is a skill that you'll use in your science classrooms and math classrooms later on as well. So to make sure that we understand how to do this, I'm going to walk through a really basic equation in part one. In this equation, we're not going to do anything new. We're just going to practice solving for x. So if we were going to solve for x, we would of course start on this left side, and we need to get rid of this denominator of 4. Remember that the division sign is, the fraction bar is just division. So we would multiply by 4, the inverse of division, multiply by 4 on both sides. On the left side, we'd end up with 2x plus 6 equals 2 times 4, 8. If we were trying to solve for x, we would of course subtract 6. We get 2x equals 2, divide by 2, and you get x equals 1. Those skills that you use to solve for x, you're going to use when you solve a literal equation as well. We're going to solve that same equation, except now, instead of a 4 in our denominator, you'll see we have a k. This is just getting us used to what a literal equation is. You'll see more than one variable in a literal equation. So if we're trying to isolate this x still, we would still get rid of that denominator. Now, how are we going to get rid of that denominator? We're going to multiply by k. Multiply by k. The k's will cancel out on the left, so we're left with 2x plus 6 equals 2 times k, which is just 2k. Just like before, we'd subtract 6. We get 2x equals 2k minus 6, and then we would divide by 2. So we get x equals k minus 3. Or another way to write that is 2x minus 6 all over 2. Or x minus, not x, k minus 3. Now let's add another variable. You'll notice that in place of our denominator, we still have k, and now we have an r. Our job in this problem is to still isolate this x. We're going to use all the same steps that we used before. We're going to multiply by k. So we have 2x plus r equals 2k. If we still want to get this x alone, we're going to subtract r. So we have 2x equals 2k minus r. And then if we want to get x alone, to get rid of that 2 out in front, we divide by 2. So we get x equals 2k minus r, all divided by 2. You'll notice that as we add variables, our answers get kind of more, we have more variables, we have more things left over. That is okay. It's totally normal. Now we're going to plug it in, let's try one more time with lots of variables. In this problem, again, we're trying to solve for x. We're going to multiply by k, multiply by k. We have 2x plus r equals f times k. If we're still trying to isolate x, we're going to subtract r, subtract r. In our final step, we would divide by 2. All of that right side by 2. So we get our final answer is x equals fk minus r divided by 2. That is solving a literal equation. Let's try some more examples down here at the bottom. In our first one down here, we're going to solve for a. So now we are trying to get this variable all by itself. if we're going to do that, think about whether you'd get rid of your multiplication first or whether you get rid of that plus b. We're going to subtract b from both sides first. Do your addition and subtraction first, and then divide. So we have ax equals c minus b. We're solving for a. We're trying to get this a alone. They're currently being multiplied. The inverse of multiplication is division. So to move that x to the other side, we're going to divide by x. In our final step, we'll get that variable a alone. And we have c minus b all divided by x. Another way to write that is a equals c over x minus b over x. Either of these is correct. Make sure that you're not just dividing one of the variables by x. Check out this next one. In this problem, we are trying to solve for w. What operation is happening between the length, the width, and the height? Hopefully you're thinking, well, they're all being multiplied. So the inverse of multiplying is dividing. So I'm going to divide by L and H. You can do that at the same time. The L's will cancel on the right. The H's will cancel on the right. So we're left with W equals V divided by LH. If you need to flip it around, W equals V divided by LH. That's totally fine as well. This one, we're solving for B. When we solve for B in this problem, you'll notice that it's in the numerator and it is being added with y. However, we cannot subtract y first. We have to get rid of this denominator of 2 by multiplying. In our final step, we're still trying to get b alone. Think to yourself, how are b and y separated? They're separated by addition. So to get the y to the other side, we're going to subtract. So we get b equals 2a minus y. Pause and go back to anything on the first page that you might need. We're going to go on to page 2. You'll notice in this first one on the back that t is inside the parentheses. It is all being multiplied by p. I would encourage you to first distribute. We're trying to solve for t. In order to solve for t, we need to first subtract p from both sides. And then we want to get t alone. Like that problem on the front side, the p, the r, and the t are all multiplied. So to get rid of the p and the r, use the inverse operation of division. To get your final answer is t equals a minus p over pr. In this one, you'll notice that the variable that we're trying to solve for is in our denominator. We're going to need to get it out of the denominator in order to solve for it. To get things out of the denominator, they're being divided, so use your inverse operation of multiplication. So we get W, C, D equals 12S. Now, think to yourself, what operation is separating the W, the C, and the D? We need to get the W all by itself. They're all being multiplied currently, so we need to divide by the C and the D in order to isolate the W. You can do that all at the same time, like divide by C and D at the same time. You don't have to do it in separate steps. I want you to pause the screen and try this problem to the right. Once you have tried that problem on your own, I want you to check to make sure that your answer looks the same as mine. P minus 2W all over 2. You could have also written it as P over 2 minus 2W over 2. In our next row of problems, we're going to start implementing some fractions, and these are actually all real formulas that you would see in a science class. We're going to first try to solve for C here. Don't get overwhelmed by the fraction. We've got this. Now, whenever you're dealing with these equations that have fractions, similar to our first day in this unit, I would encourage you to clear out the fraction completely at the beginning. We need to clear out the fraction by getting rid of that denominator of 5. To get rid of the denominator of 5, we're going to multiply the entire equation by 5. Make sure you multiply every number inside by 5 because it's an equation and you have to keep it balanced. If you change one number, you've got to change them all. 5 times f is 5f. 5 times 9/5 c would give us 9c, plus 32 times 5 would give us 160. Now we're still trying to solve for c, and we're going to continue on doing that. Go ahead and subtract 160. And then in your final step, divide by 9. So C equals 5f minus 160 divided by 9. I want you to look over at this equation on the right and try to think to yourself, what would I need to multiply that equation through by in order to isolate this b right here? Hopefully you're thinking the number that I need to multiply the equation by to get rid of that fraction is 2. 2 times a is 2a. Now, even though it looks like 3 separate pieces over here, all of these are being multiplied. So that 2, when it multiplies by the 1/2, is 1bh. So you're just left with bh. In your final step, to solve for b, you would divide by h and get b equals 2a over h. Pause the screen and solve for y in your final equation. After you've tried that problem on your own, I want you to check yourself. You should have distributed the 8 to clear the fraction and gotten this step right here. We want to isolate y. You should have subtracted x, and then in your final step divided by -2. In our final problem, we're going to try out a word problem. Meryl has to build a rectangular pen for her dog, Doug. Meryl has P feet of fencing for this job. She decides that the width of the pen will be 15 feet. Write an equation describing the relationship between P and the length of the pen, L. So we've got a rectangular pen here. We know that the width is going to be 15 feet. We don't know the length. You could have interchanged these, by the way. If you put width on the other side and then length up top, that's fine. We know that all this together has to be P amount of fencing. So we can write an equation. The perimeter of the fence, or the amount of fencing she needs, P, is equal to L plus 15 plus 15. Or, if you're able to see that quicker in your head, it's just 2L plus 30. So right there, we have just written an equation describing the relationship between P and L. P is equal to 2L plus 30. Now we're going to practice using our skills to solve for L. Go ahead and pause the screen and make sure you can do that on your own. When you're solving for L, you should have first subtracted 30 from both sides and then divided by 2. There are 3 ways you could have written it: P minus 30 over 2, or you could have divided each piece by 2, P over 2 minus 30 over 2, or P over 2 can stay the same, but 30 divided by 2 is 15, so P over 2 minus 15 is the same thing. Any of those 3 is fine. Don't forget to log back into office hours if you have questions. I would love to help you out and do some more practice problems with you if you need to. If you don't need help, then make sure you're starting that assignment.